In problem 1, part B, we have been asked to calculate the rate of return of an investment for year 1 and year 2. So if we just draw a timeline so we understand what's happening, we've got time 0, time 1 and time 2. If we invest $100 at time 0 and after 1 year the investment decreases to $80 and then in the second year goes back up to 100, what is the rate of return in year 1? And what is the rate of return in year 2? So this is for part 1. Now, the way that we calculate that is we use the formula, the cash flow in year 1 minus cash flow at time 0 divided by the cash flow at time 0. So that's basically saying the change in investment divided by the beginning investment will give you the rate of return. So that's 100 minus 80 over 100. So that is minus 20%. Now in year 2, C1 minus C0 over C0. So in year 2, the ending cash flow is 100. The beginning investment is 80 and divided by 80. And we get 25%. Now, in part 2, if we're asked to calculate the average rate of return, minus 20% plus 25% divided by 2. So minus 20 plus 25% divided by 2 gives me a 2.5% average return. Now something doesn't make sense here, because if we start with $100 and we end with $100, then we would expect the rate of return to be 0. So this is one of the issues when we calculate rates of return and we just average them over time. Now in part 3, if we calculate the annual compound rate of return using the formula S equals P outside of 1 plus I to the n, we will see what we find, and hopefully we get an answer of 0, because if we start with $100 and we end with $100 over a 2-year period, then we'd want our rate of return to be 0% per annum. So S is 100, P is 100, N is 2, and I is what we're trying to find. So 100 equals 100 outside of 1 plus I squared. So divide both sides by 100 and I'm left with 1 equals 1 plus I squared. If I then do the same thing to both sides and I'm left with 1 to a half equals 1 plus I. So the square root of 1 is 1. So that leaves me with 1 equals 1 plus I, and I is equal to 0. So what we find here is that if we calculate what's called an arithmetic return, we cannot average them over time for a compound investment. However, if we wanted to calculate the correct annual compound rate of return, which we refer to as a geometric return, then we need to put it into a compound interest formula so that we can calculate the correct return over that 2-year period. Now, whilst in part 2, those average rate of returns are correct for the periods between 0 and 1 and 1 and 2, we run into problems when we start to average a rate of return, or we try and add them together to get an understanding of how the investment has changed. To get an understanding of how the investment's changed from a compound point of view, we therefore need to use compound interest rate formulas and compound interest rates.